Hello, everybody. I'm Paul Beckwith, and we're at the Baku, Azerbaijan COP29 climate conference. And I have the pleasure of having Dr. Hugh Hunt with me at the moment. Before I say anything else, I just want to thank the International Society for Ecological Economics for getting badges for the Climate Emergency Forum to attend. Now, just a couple words about Hugh. He's a professor of engineering dynamics and vibration at the University of Cambridge, but he's also deputy director of the Center for Climate Repair at Cambridge, and his primary interests are in the fields of renewable energy and geoengineering, and you were the lead engineer in the SPICE project, which was technology that looked at ways to cool the Earth by 2 degrees Celsius if CO2 emission targets are not met. And very interestingly, you've been the lead engineer in 3 award-winning documentaries. I've seen them all, by the way. Dam Busters, Digging the Great Escape, and Escape from Colditz. You've been to a number of COPs. What are your impressions so far? You just arrived. And what are you hoping to do this week at the COP?
Well, thanks very much, Paul. The first COP I went to was COP21 in Paris, and the 2015, and it was at the very end of this SPICE project. And our SPICE project outdoor experiment, got cancelled. And one of the big questions for me at the time is, well, why was it cancelled? What's wrong with this geoengineering subject? Why are people so frightened of it? Surely we need to do research. Anyway, I naively went along to COP21 thinking, yeah, no, these people, I'll persuade them. They'll listen. And boy, I've been to all the COPs other than Spain. Of course, every year, the conversation about geoengineering becomes perhaps even more distant than every year before. And yet at the same time, we're not getting any closer to getting off fossil fuels. Now, I believe that there's no chance of dealing with climate change by emissions reductions alone. And I think that carbon dioxide removal, greenhouse gas removal, is very important in addition. But even those two alone are insufficient, because we will get to 2.5 degrees, 3 degrees warming, even if we do both of those things. And we've got to buy us some time trying not to exceed, say, 2 degrees. And that will require albedo enhancement, solar radiation management, reflectivity enhancement, whatever you want to call it. And the two ways that I think are kind of looking promising, one is cloud brightening. We know that clouds reflect sunlight. And if we can improve their ability to reflect sunlight by around the planet by, say, 1%, well, that might give us a degree of cooling or thereabout. Likewise, volcanic eruptions, Mount Pinatubo back in 1991 in the Philippines, that caused an increased reflectivity of the northern hemisphere, and we got maybe 0.5 degree cooling for the best part of a year. So could we engineer one or other or both of those mechanisms for cooling the planet? And that's what our Centre for Climate Repair is interested in doing. I grew up in Australia, and I looked like most Australians, bought into this wonderful myth that, flying and burning fossil fuels, that's just what we do. It's fantastic. What a gift from God, I think somebody said just recently.
I wonder who that was.
I wonder who that was. And it's interesting now, 40 years on from when I graduated from the University of Melbourne, um, we're really looking hard at this question of the burning of fossil fuels. Switching it off is not sufficient, in my view. So, Paul, back to you, but I kind of covered a few of the things you mentioned.
Yes.
Maybe you got some more questions.
Those were the easy questions. So let's get to the tougher question. Actually, so you mentioned first of all, the term climate engineers or geoengineering scares people, some of the public, but I don't think it's mostly the public. I think it's mostly people, other climate activists and other people in the climate community. And a few years ago, it was climate scientists. So I don't understand because engineers are generally highly respected in our society. You know, engineers build bridges, they build roads, they build buildings, and people put a lot of trust in these structures, you know, our engineered society. So I don't understand. I think it's misplaced propaganda against engineers or something.
And that's really interesting because the amount of trust that we put into engineers to design aircraft and buildings and bridges, where things, if they go wrong, uh, gosh, you know, consequences. Yep. And also, we do trust engineers to be ethical and responsible and to consult. You know, if there's going to be a new bridge, we've got to make sure that the approach ways, you know, knock down the fewest people's houses and deal with noise and deal with pollution. It does astonish me that this idea that engineers can't be trusted with the ethics and governance and morals of geoengineering. Like, oh, we've got to get social scientists in to do this because we can't trust the engineers.
Yeah.
And it was interesting in a meeting I was at on geoengineering in Berlin, where I said about our SPICE project, the experiment that we wanted to conduct. We probably wouldn't have been able to do it anyway, because we discovered that this 1 kilometer hose had a hole in it, and we wouldn't have been able to do the experiment. We'd have to get a new hose, and that would have delayed the whole experiment by a year, and so. And somebody said, "You never told us about that. That's just proof that you can't be trusted." And I said, "Well, the reason we didn't tell you about it is because the experiment had been cancelled, and it was only when we were trying to figure out what to do with this hose, we found this hole." Yeah. So it said, "Oh, by the way, in this cancelled experiment, let me tell you about the hole we found in the hose." You know, what is it? Anyway, it's annoying.
Well, I'm a big believer in MacGyver technique, so I would just take a roll of duct tape and wrap it around and fix the hole, but maybe the pressure's too high.
We were going to do that.
So there has been, the problem with climate is its unintended consequences of burning fossil fuels and putting greenhouse gases in the atmosphere at ever increasing rates. So it isn't an experiment tinkering with the earth, but it's unintended. And let's talk about the reduction of sulfur in marine shipping fuels. So the International Maritime Organization reduced the sulfur in shipping fuels, I think about 2017, and then they ratcheted it up in 2020. And according to some of the work by James Hansen and other scientists, they've shown, I think their work's pretty conclusively shown that the reduction of sulfur in shipping fuels has led to less aerosols above the roots of the commercial shipping, mostly of which are in the Northern Hemisphere, and that's caused a warming in the Northern Hemisphere and a warming of the ocean. So this is another unintended experiment, but these things, and of course volcanoes happen naturally and cause cooling, significant cooling. So all of these things point to I think the fact that the climate response is extremely sensitive to sulfur in the stratosphere. So, I mean, it's, you know, if we have a choice between having global food shortages or putting some sulfur in the stratosphere, you know, I think the I think what we're going to do is clear. I think it's an unstoppable technique. Somebody is going to do it, whether it be, and are you working to contact Elon Musk to talk to him about climate change and about getting, he just made $70 billion from Tesla because it went from 220 US to 350 US in about 3 weeks after just before and after the election. So that 70
What election?
billion, that $70 billion could go to these sort of things. We got to protect our global food supply, right?
So you've mentioned lots of things. Firstly, let me say that sulfur in shipping fuel, you might think, what was it there and why was it there in the first place? Um, uh, Sulfur is naturally present in oil when it comes out of the ground. And over the years, we've realized that sulfur leads to acid rain, sulfuric acid, all that sort of stuff. And we want to try and get rid of it, but getting rid of it is fine. Getting it out of the fuel is fine, but where are you going to dump it? So it turned out the easiest place to dump it was in this dirty shipping fuel, increase the sulfur in the shipping fuel, because no one out there will ever notice. So bit by bit, shipping fuel became more and more sulfurous. And that's why when you go to a harbour, the smell, well, at least less now, but certainly was the case. The smell of a harbour was very sulfurous. Now the sulfur coming out of the shipping, the funnels of the ships, that goes up not into the stratosphere. Generally speaking, gets up to sort of cloud height, where the aerosols nucleate cloud droplets. So you get these. If you look at satellite images, you would see these ship tracks, and these are clouds down at maybe a height of 1,000 meters, 3,000 feet. So in that altitude, creating more reflective clouds is clear evidence that this idea of cloud brightening, particularly at sea, has a good chance of being effective. But then sulfur was also emitted. 10 million tons was emitted thereabouts by Mount Pinatubo back in 1991. But that sulfur went up, as you said, Paul, right up into the stratosphere to a height of more like 20 or 30 kilometers. Now, the questions on these sort of kind of two sort of altitude brackets, can we make clouds, nucleate clouds more effectively at a height of 1 kilometer? Well, that can be done using ships and spraying seawater to make saltwater nuclei. So that's relatively, the technology is relatively straightforward, but the scale, a lot of ships, can we scale up to make that work? That's why we need to do the research. And then in the stratosphere, you need much less stuff in the stratosphere to do the reflecting, partly because clouds only last a few days, whereas up in the stratosphere, the stuff you put up there can last 6 months or longer. But here's the rub. It's quite hard to get things up. Ordinary planes only fly to 10 kilometers. Getting stuff up to 20 kilometers, and the atmosphere is getting quite thin, and wings don't work nearly so well up there. That's a technical challenge. So there's a couple of really good technical challenges tied up in these technologies, which is why we need to do the research. Now, if you ask Elon Musk how much research he did on the Tesla and how much research he did on the Falcon Heavy and how much research he's done on any of his other enterprises, he will tell you absolutely that research, that's where it all starts. And and some things work and some things don't work. And the things that work, you think, hurrah, and then you try another experiment and it doesn't work, and eventually you get your fantastic Tesla, and then it crashes. And you think, oh, okay, well, so in the geoengineering kind of world, what we want to do is to look at the potential benefits in terms of bringing down global temperatures, potential benefits on floods and droughts and hurricanes and all these things that we keep on hearing about. And we not only need to do the research, but then as we gradually tip ourselves towards deployment, which I feel is inevitable, we will learn by doing. And there may be ups and downs and mishaps. But have there ever been mishaps in our progress towards learning to fly planes? Have any planes ever crashed, as far as you know, Paul?
I think maybe a few.
Maybe a few. And yet we're thrilled to bits with planes.
Yeah.
So I just think, as engineers, we want to move forward ethically, responsibly, but we've got to make progress.
So let's talk about, so you mentioned SPICE. Based on what I've seen at the COPs over the years, there's more talks and interest in carbon dioxide removal, methane removal. Everybody talks, of course, about fossil fuel emissions, and it doesn't seem to work. We don't seem to be ever able to reduce emissions. And also SRM, there's many sessions on SRM. So I think that the talk has come, and we need to do the research for sure. So I suspect, I could be wrong, but if you were trying to do the SPICE experiment today, I think you might just be able to push it through and do it. That's my guess. So are you working on SPICE 2.0, SPICE 3.0? What would you hope to deploy maybe in the next few years, given the climate crisis is spiraling out of control with the extreme weather events? It's just, so, I mean, the urgency is much, much greater now. And I tell people, I think we're heading to global food shortages within a decade or so. So what can we do quick that would really maybe sway people's opinions when they saw something happening?
So let me just say, on the SPICE project, our SPICE experiment was only going to be at a height of 1 kilometer, pumping about a bathtub full, 100 liters of tap water, fresh water. And this was going to be in Norfolk, in England, and it was at a time in the summer of 2013 when they were having a really serious drought. And the farmers in Norfolk were saying, please, can you do more than 100 liters? And so the idea that it was going to be a downer for them, all sorts of misconceptions. But you ask me, would we do that again? And how would it go? We wouldn't do that experiment again, because it wasn't intended as anything other than dipping a toe in the water. Let's just get used to the idea of pumping. So having the same tether for pumping as for holding the balloon. So pumping water up through a hose. No one had ever done that before. Yep. But now, SPICE 2.0, absolutely. We are applying for funds whenever we can, with the idea of, firstly, flying a balloon at 20 kilometers, 15 kilometers. The idea is that the balloon would then be above the jet stream. And the jet stream is where the strong winds blow. So the balloon itself would be in relatively calm winds. No one has ever tethered a balloon up to that height before. So it needn't be for geoengineering. It might be for telecommunications. So I'm very interested in working with telecommunications people with regard to tethering a balloon and therefore some kind of communications platform. The higher up you are, the bigger the coverage you have for your 7G communications. Right. Then the other technological thing is, how do you pump stuff up that sort of height? We can kind of separate that out, these bits of the technology. All of that, as far as I'm concerned, is in a way icing on the cake, because what we do know is that we could deploy some uh, um, um, scrap heaped Boeing 747s, which we could get them flying again. We could deploy those to carry 100 tons each of whatever it is, high enough to release it into the stratosphere. We can do it that way. So the technology is pretty much ready to go if we wanted to,
Yeah.
without too much more research, to take, say, 100 tons of sulfur dioxide and release it in the stratosphere. 100 tons, that's a huge amount. Hold on a second. Mount Pinatubo was 10 million tons. So 100 tons is a 10 millionth scale. It's 10, so
Yeah.
it's 10 to the minus 5
Mm-hmm.
of a full scale experiment. Now, if I were to be testing you, say, for some new drug, and I said, right, I'm just going to put a little bit on your, that's a 10 to the minus 5 experiment, putting a tiny quantity just to see if you have some allergic. Okay, that looks fine. So you know what we're going to do? We're going to spread it. We're going to
Spread it out.
and the reason for doing this, Paul, is that if we can make this drug work, then this terrible illness that you've got, you might survive.
Yeah.
But if we don't do this, I'm sorry to say, Paul, it's not looking good. And that's where we are with these geoengineering experiments.
Yeah.
We can't, I just don't think we can pretend anymore that there is a world without geoengineering. Because otherwise, if we carry on the way we're going, we will have food shortages within 10 years, as you say. The Arctic will be summer ice free in the next 10 or 15 years, and that's going to lead to more rapid melting of the Greenland ice shelf. And before we know it, we'll have a meter or perhaps several meters of sea level rise with the combination of the Arctic and the Antarctic. And it might not be in our lifetimes, but for us to say to our grandkids and beyond that, oh, well, we didn't think it was important, so we did nothing about it. And so that's the question. The question, I think, for me is, if we want to be ethical and responsible as engineers, I think it's ethical and responsible to do the research and to implement, if at all possible, technologies that are going to make a difference to the future for our kids and grandkids.
I got my engineering physics degree, and when we graduate, we have we have various rituals where we have to, pledge to be ethical and design things safely. And I'm sure you have similar things. So there's one more thing I just wanted to ask you quickly, which we didn't touch on. And so we've been talking about solar radiation management. We talked a little bit about carbon removal. I mean, the UN is saying that we've got to take out 10 gigatons. We're putting in 40 gigatons, and Sean has been talking about that. Sean Fitzgerald last week in some of his work, and so have you? Can you talk to us a bit about methane removal, because methane is a very powerful greenhouse gas, as we all know, and if we could remove some methane from the atmosphere, we could make a big difference to temperature on a short time scale. And we're talking about a third of the warming with methane. So, and this is a huge risk. You mentioned the Arctic melting. I mean, there's tons of methane in the top meter of the permafrost in the Arctic, and if that starts coming out, then methane levels in the atmosphere will skyrocket. So, I'm talking about things like different radicals, like some chemistry to break down methane quickly in the atmosphere. I mean, have you thought much about that?
So, methane, as
Methane,
we who invented the language like to call it, is indeed a potent greenhouse gas. You can argue a lot as to whether it's 25 times more potent than CO2 or 120 times more potent than CO2. It depends on timescales, because methane naturally decomposes in the atmosphere. So unlike carbon dioxide, which sticks around for 500 years, 1,000 years. So I'm in two minds on the methane front, because yes, of great concern is keeping the methane locked up in the permafrost in the Arctic. But I've been astonished in recent months, last couple of years, at how much more easily it's become, using satellites and other instruments, to see where the methane is leaking from gas pipes and coal mines and oil platforms. And so the dishonesty we have amongst the petroleum, the fossil fuel companies, the self-regulation which we've been promised on methane leaks, isn't happening. And I also think that the methane that's leaking from in agricultural our agricultural sources, we're beginning to find out from satellites and from other monitoring tools that we can see where the methane is coming from. And I think that we're going to deal with those methane emissions much more effectively. And if we can manage to avoid losing the Arctic, then I think we may contain the methane problem. Now, if we don't contain the methane problem, we need to have at the ready technologies to deal with methane. And that is why our Centre for Climate Repair is very actively looking at technologies to deal with methane. And but it may turn out in 5-10 years' time that is not as necessary. But we'll wait and see. What I'm certain that will be necessary will be the albedo enhancement, which will continue to be the strongest element of our Centre for Climate Repair.
Well, it's been a pleasure chatting, and for every COP I come to, I have to buy a new hat. So this is of course, Sherlock Holmes hat. So I think it's fitting for me to say climate engineering is, the idea of actually doing the role of climate engineering will play is going to get larger and larger, and it's an absolute necessity. And I would say that's elementary, dear Hugh.
Thank you, dear Paul.
I want to thank everybody watching, and please subscribe to the Climate Emergency Forum. And I just want to thank once again the International Society of Ecological Economics for badging Heidi, Charles, and myself. And you're with the ecologist, right?
The ecologist.
And
I did say as I went to get my water bottle, and they said, "Oh, you're from the ecologist." No, I'm from the psychologist. And they said, "Oh, no, it is the ecologist, but I think we need more psychologists around."
Yes, absolutely. Well, thank you, and thank you for watching.